And now we're going to talk about reciprocals. We need to talk about a reciprocal because that leads into what we need for division. So I've had a student refer to reciprocal as the flip or a flippy thing. And that's what's going on. Two numbers whose product is 1 are reciprocals of each other. They're also called multiplicative inverses of each other, because if I have one and I multiply by the other, it turns into a 1. So when we get to equations later on, this is one way to cancel out a number in front of the variable when you want to get the variable with no number, or a 1, just one variable alone to figure out how much one variable is. This is one of the skills we're going to use. So the reciprocal of A over B is B over A, with, of course, the ever important caveat that A and B are non-zero, because if one of them was 0, one of those two is not a real fraction. So literally all we do is flip it over. Now, you may have a vague memory of a negative reciprocal or opposite reciprocal from math, which I don't think we do in this class, but if we were going to talk about graphing lines and two lines that are perpendicular meet in a right angle, those have opposite reciprocal slopes, or flippy opposites is what one of my students coined it as. This, we don't change the sign. Here, the reciprocal, just reciprocal, has the same sign as the original. So that way, when they multiply, they turn into a positive one. So if our first number is positive, the reciprocal is positive. If the first number is negative, the reciprocal is negative. Okay? That way they multiply to a positive 1. If you're not sure, multiply, see if they become positive 1. All right, so 2/7, the reciprocal of that, 7 on top, 2 on the bottom, reciprocal done. Negative 24/5. It is still going to be negative, but now it is 5/24. So here, let me show you what happens when we multiply by the original. Now I have 2 times 7 over 7 times 2. So the tops are the same, the bottoms are the same, they're just backwards, but multiplication of numbers is the same forwards and backwards. So all the numbers would cancel out, and they cancel or divide out to 1. Same thing over here. If I multiplied by negative 24 over 5, the negative times negative is positive. 5 on top, 5 on the bottom, 24 on top, 24 on the bottom, positive 1. Now a little more interesting. We just have the number -4. But to do our flip thing, I got to have a top and a bottom. Right now I just got a number. So what did we do before when we were missing a number on the bottom? What can I divide -4 by and still have it equal -4? 1. Oh, bad handwriting. So -4 divided by 1 is still -4, but now I've got an A over B, so I can flip it and get my B over A, which is still negative. But now it's -1/4. So 1/4 of 4 is 1 whole. If I have 4 wholes and I take 1/4 of that, that's just 1. And then 13, 0 over 49 is just 0. But the reciprocal of that, 49 over 0, is not a real number. So there is no reciprocal, or no reciprocal exists. Let's just type that. There we go. All right. So when we are doing division, in general, to divide two non-zero numbers, we can multiply the dividend by the reciprocal of the divisor. This is how we divide a fraction. D-do-do-d-d. Way too many D's in that sentence. To divide two fractions, multiply the dividend, English, the first fraction, by the reciprocal of the divisor, the second fraction. So some people have the moniker for this keep, change, flip. You keep the first one as is, you change the sign to multiplication, and you flip the second one. So realistically, you type this on the calculator. There is a caveat to that. When you are multiplying by fractions, it'll work out okay, but with the division, because you're usually using the division symbol to type a fraction and the division symbol in between the fractions, you need to use parentheses, like what's going on here in 15. You put parentheses around each fraction, and then you have the division symbol in between the two sets. So not a big set and another even bigger set, but a set around one number, a set around the other, and put the division in the middle. Otherwise, you're taking the first number and just dividing it by all three of the other numbers singly, and you don't get the right answer then. The calculator is doing what you told it, you're just not typing it in the way the calculator needs to understand. Or you can do the keep, change, flip, and then just type the multiplication into the calculator, and then you don't have to worry about the parentheses. So that is what we're going to practice. So to figure out what 3/16 divided by 18/8 is, keep the first one, 3/16, change it to multiplication, and then flip it so it is 8/18. Now we just need to do any reduction that we can. So 8 and 16 are both divisible by 8. So 8 divided by 8 is 1. 16 divided by 8 is 2. And then the 3 and the 18, the 3 actually does divide into the 18. So the 3 divided by 3 is 1. The 18 divided by 3 is 6. So I have 1 times 1 on top, 2 times 6 on the bottom, 1/12. And again, I am totally fine with you guys just crunching this on the calculator, as long as you can look at your answer and realize if that makes sense or not. So 3/16, and then when I flip it to 8/18, I now have two fractions that are in between 0 and 1. When you multiply a number in between 0 and 1 by a number in between 0 and 1, it stays between 0 and 1. So the bottom number will be bigger than the top number. 1/12 is between 0 and 1. So this makes sense, like gut check. You can also, if one of them ends up being bigger than 1, you can figure out what the nearest whole number would be, do that multiplication, and then see how the answer you got relates to that, if it makes sense, like in a size-wise, like my answer should be a little bit more than this or a little bit less than this. We'll try it on the next one. All right, so we keep the -5/11. Change this. I'm going to use the dot for multiplication. I don't like the way my x looks. Not for, because it's not my x, so yeah. But flip the second one, so this is -9/4 now. Wow. There is not a single thing. 5 and 11 are prime, and 9 and 4 are coprime. They don't have anything in common, so we just multiply. Negative times negative is positive. So we have 45. Yeah, 5 less than 50 is 45. And 11 times 4 is 44. So we ended up with something a tiny bit bigger than 1. Now let's look at what we were multiplying. 5/11 is really close to a half. 9/4, 4 would go into 9 twice, so it's a little bit bigger than 2. So something close to a half and something a little bit more than 2. A half times 2 would be 1, and we got an answer close to 1. Now, if you crunched this on the calculator and got, it it'd be like 5 over a ridiculously huge number, then that means you didn't use the parentheses in the calculator. So basically, if you don't put the parentheses in, whatever the first number is going to be the number on top of the fraction or something reducing from that. All right. So 16 here, if you type this on the calculator, it would actually work out fine because the second thing is just a number. Although some calculators get really annoyed if you have division followed immediately by the negative sign. So that's one of the reasons why the book types it this way. It's left over from, I think, programming more than likely. All right. Still, again, we can do this. Keep 24/5. Change it to multiplication. And then that negative 18, to give it a flip, we give it a 1. And the negative on a fraction, you can write it with the top number, you can write it with the bottom number, you can write it right in front of the fraction. I don't recommend the third because then it gets lost in your handwriting. But whether it's on the top or the bottom doesn't matter as long as you don't put it both. All right, so 24 and 18 actually have 6 in common. So I can divide both of those by 6. So 6 goes into 24 4 times. 6 goes into 18 3 times. And this was positive times negative, so we know our answer should be negative. Doesn't have a pair to become positive. 15 was a pair, so it's positive. All right, so 4 on top, 5 times 3 on the bottom. So 4 times 1 is 4, 5 times 3 is 15. There's our fraction. Now I know the way I multiply fractions is a little bit different because I'm simplifying before I multiply, but that way you make the numbers smaller and then they multiply bigger rather than you multiply them together, they get bigger, and then you have to try to figure out how to make them smaller. And you do it this way, you're not having to play around with big numbers so much. But again, calculator, use your tools. Like, you're responsible for knowing how the variables will cancel here, but the number crunching part, you can let the calculator do it. So like 17 here, well, let's do our flip, keep change flip first. So a negative 9mn over 4, change it to times, still negative, but the 32 is on top, and 15n is on the bottom. That's my roommate yelling at her cats, if y'all heard that. Hopefully you did. All right, so the number part, you could type in negative 9/4 in parentheses times negative 32/15 in parentheses, enter, and the calculator should give you what the reduced product is. Then if there's any variables left over, just put them in the appropriate spot based on your working by hand. So you guys are still responsible for figuring out what happens to the letters because the calculator won't do that. But you can get the number part taken care of. All right. So this one here, let's see what we got going on. We got an N on the bottom and an N on top. So those go away. So we just have an M on top as our leftover. So we know we're going to see that in our final result. I have a negative and a negative, so the result is going to be positive. Now let's see, 9 and 15, 4 and 9, no, so 4 and 32, 4 can go into 32. 32 is a whole bunch of 2s, 4 is 2 2s. So 32 is 5 2s, 4 is 2 of them. So if I cancel 2 out of the 5, I have 3 left. So 2 times 2 times 2 is 8. So if I do this division, I will get a 1 on the bottom and the 8 on top. Now the 9 and the 15, 9 doesn't go into 15, but they both do have a common factor of 3. So I can divide both of these by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. So I have 3m times 8 on top, that is 24m, because the signs canceled out. And on the bottom, 1 times 5 is just 5. So 24m over 5. There's our answer to that craziness. All right. Now, the last one, we got A's and B's and exponents. But like in these, I kind of find it fun because once you get it set up, like stuff starts to cancel all over the place. I have weird definitions of fun, I know. All right, so keep the first one. 20a squared over b. Change the sign. And now b to the third over 4a. All right, so let's do some changing. So this a squared and this a on the bottom. A squared, I'm going to cross it off and write what it means, a times a. And I can cancel 1a with 1a, one from the top, one from the bottom. So that leaves us with 1a left over on top. And you can, as you work, like start filling in the stuff that you figure out. So there's an a there. Now our b's. Single b on the bottom, b to the third on top. So again, I'm going to write what that means. It's 3 b's and one of them will get canceled. So we have 2 b's left over, also on top. Traditionally, we write the letters in alphabetical order. Realistically, it actually doesn't matter at all. If you type b squared a on Alex, it'll count it right. And then I have 20 and 4. Well, 4 goes into 20 5 times. So there we go. So I wrote the fraction bar. Turns out we didn't even need it. So sometimes I'm like, oh, look, it was a box, not a fraction. Yeah. All right. So it's just a, let's see what cancels. And if you don't notice the biggest number right away, like just go with your evens. A lot of times it's 2s and 3s. Like sometimes it'll be a bigger number, like we did see, like the 6 is just 2s and 3s. We saw 5s and 7s earlier, but yeah, usually it's a bunch of 2s and 3s. Now, applications of multiplication and division of fractions. All right, so our first one here, how many fourths are in 7 halves? So this type of question is, we're measuring how many 1/4 are in 7 halves. So it's like if I had 7 1/2 cups of flour, how many 1/4 cups are there in that whole mess? How many 1/4 could I measure out of 7 1/2 cups? So this is where our copies of the unit fraction kind of come into play. Instead of saying 7 halves, I'm saying 7 1/2. So you can actually just like write it out, like here's a half, and that half will give me a fourth and a fourth. And then there's 7 of those, so I'm going to have 7 times a pair of 1/4 is going to give me 14 1/4 in 7 halves. So I just did a lot of talking and hand waving. But here is what's going on. So I have, so 7 halves, I'm going to draw a whole bunch of holes. All right, so there is 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. So I didn't need that last circle, and 7 halves. So I'm going to erase that and just draw the half circle. Now it's how many fourths are there? So my whole circle, I can cut it into fourths. One cut would be on the same line as the half line, and then the other would go like so. So I'm just going to put the horizontal line on the rest. And then we literally count. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many 1/4 are in 7 halves? 14. Now, originally I started out saying this was a measurement division problem. So what we are doing is taking 7 halves and dividing it by 1/4. That is the numeric mathematical calculation that we just did with a drawing, which this is the kind of drawing like a 4th or a 5th grader could actually produce if they've been like understanding their math. And if they haven't, it's not them. Math is not easy to teach to kids. So number crunch wise, this would be 7 halves divided by 1/4. So when we ask how many of these things are in that, like how many 2s are in 26. So that's what I do whenever I see a question that has fractions and I'm like, I don't know how that works. So I change it to numbers I know better. How many 2s are in 26? 13. How'd I get 13? Or maybe you don't like 26. How many 2s are in 20? There are 10 2s in 20. Well, how'd you figure that out? I did 20 divided by 2. So how many 2s are in 20? The last number, 7 halves, divided by how many 2s divided by 2, or in this case, divided by 4th, or 1/4. So that's how I know that order is correct. And why I know it's division, not multiplication. I took the original question, put in numbers that made more sense. And if you put the numbers in backwards, how many 20s are in 2? Your brain kind of goes, there's not a 20 in 2. Then swap the numbers. Because you want the question to be something you can kind of gut answer and then use that answer to figure out how to translate the question, the statement. All right, so if we keep change flip, this becomes 7 halves times 4/1. 2 goes into 4 2 times. 7 times 2 is our 14. So we did it visually and we did the number crunching. Cool. I was really excited about drawing that picture. That's exactly what I was doing last spring. So cool to see it come up. A high school budget was $17 million last year. Oh my goodness. Well, I suppose if you're including all the teacher salaries and the football coach's salary, which is more than everybody else's salary, no, I'm not bitter. It might actually get that high. If 4/21 of this amount came from donations, how much money was donated to the high school? Okay. So remember I said before, our magical word of. So 4/21 of this amount. This amount is thus referring to the ridiculous 17 million, blah, blah, blah. So we want to know what 4/21 of 17 million is. That of means times. So I want to know what 4/21 times 17 million, blah, blah, blah is. Calculator. No one expects you to divide 21 into 17 million and change by hand. This is a calculator question for sure. But let me write what we're telling the calculator to do. So when I have an of question, I usually write the thing before the of first. So 4/21 of, change to times 17859,030. So on the calculator, just to be safe, I get kind of paranoid because when I was young, calculators were still kind of stupid. So parentheses were the way you had to CYA. Alrighty, so I pull out my trusty calculator, because I'm pretty sure my other one is at school and I ain't driving an hour for it. So open 4 divided by 21, close, times 17859,030. And oh, look at that, we get a pretty whole number. It's 3,401,720. Wow. I'm sorry, my brain just can't conceive of a high school getting donations of that size. Maybe if it was from a lot of different sources, maybe. But yeah, no. I think this is very much one of those Mathland questions. In Mathland, yes. Sure, high schools have that kind of budget, yeah. All right, but when they ask this kind of question, especially when you see numbers that huge and crazy and then the fraction is kind of expect it to come out to a nice number. So I would actually question it if it didn't come out to a nice number. And by nice, I mean there's no decimal. Okay. So Maria's home loan is $135,000. That's a decent size. If she has paid off 2/25 of the loan, how much money does she still owe? Okay. So first things first. She's paid off 2/25. So usually when we get that as like a front statement, then the follow-up question is how much has she paid off? But that's not what they asked here. They asked how much does she still owe? So we're going to have to do an extra step here. And this is like the closest the book gets to a trick question, is asking a question you weren't quite expecting, but it's like one extra step to get to that answer. You can answer it. You just have to pay attention that they asked it weird. All right, so if she's paid off 2/25 of the loan, there's our lovely of. And I'm going to label this in front. This is what she has paid. So 2/25 times 135,000. Well, I know 25 is going to go into 135,000 nicely. Let's just crunch that up. 10,800. Okay. So that's what she's paid. She's managed to pay a little over $10,000, almost $11,000 of her 135,000. So how much does she still owe? How would I figure out what she owes? That's what she's paid. That's her total loan amount, the 135,000, and we're going to subtract off that 10,800. And we get 124,200. So she still owes 124,200 on her loan. Her home loan, sorry, her mortgage. Now, the reality of mortgages we will tackle way later in the semester, but this is not accounting for interest at all. The interest on this loan would make this much more painful. The amount that she would have actually paid down on the principal would be far less. Yeah, when you see those numbers, it's going to be a, wait, what? Yeah, you start to see some of the inequities in society. All right, that is it on multiplication and division. See you soon.